Good morning, everyone. This is a tutorial on how to use podHimod. So that's my version of Ubuntu and my version of MATLAB. Now on MATLAB, if you go on podHimod under test suite, you see some test case, and by choosing the test rectangle, we'll do a test on the on a rectangle, on a parallelepiped. So first of all, we create an object domain decomposition solver, and we can declare the number of subdomains. We have 3 parts. We declare the number of domain decomposition iteration. I can put 3 because it's going to be faster. That's going to be the file where we have the parallelepiped coordinate that we need to switch from one to the other. So if I go there, I see this file. The core folder, which is 2 directories above, and the FreeFem folder only if we want to use a reference solution computed with the FreeFem. Then we decide what kind of domain will be the left and right domain. So here we decide to use parallelepiped for the left domain and parallelepiped for the right domain. And in the central domain, we will use a pod solver. And the mesh is going to be a structured cube 1 by 1 by 1 with 0.1 of element size, and we generate here the mesh for the element size. We define some quantities like the name of the data file, the name of the training data file for the POD. So here we see the data file where we have the forcing term, basically the advection reaction diffusion equation, with also the name of the boundaries. When you create the mesh file, you can know which are these boundaries. Here 2, 3, 4, 5 are the sides. 1 is the inflow and 6 is the outflow. Coming back here, now we can set where we're gonna store the snapshot for the POD, and it's in the folder snapshot here. Then the training dimension and the minimum and maximum value for inflow and outflow. Here it's between -10 and 10, and for the coefficients as well. The coefficient is the one we have here for the transport term, the diffusion term, and the reaction term. Then we decide if we want to use point by point for the parameters of the pod, or if you want to do an interpolation, which degree will be 3. We don't use the interpolation for now, and we define the tolerance. Next, we can define a FEM solver for the reference solution. If you don't need the reference solution, you don't need to use that part. We call setup. That's gonna set up some subfolders and pass information between the solvers. And we can already train. We train the pod. Here it's false, but I'm gonna put true. Then I want to solve the problem. I want to solve it with POD. So I put true here. And calling this, we solve the problem. Then I can compute the reference solution of this solver and read this reference solution. Then I can compare it between the finite element solution that I computed before and our composed solution of parallelepiped, POD, and parallelepiped again. Finally, I load a previous solution that I had, and I compute the error with respect to that solution. This solution has been computed with the FreeFem, and it's a solution with high accuracy, let's say. So let's run all of this. Just to show you, here we check that the meshes are in rectangle, but we don't need the meshes in this case because they're all generated manually. But just to show you, if I go under Gmesh, rectangles, I see this file that's going to generate the meshes, and up here, if I go in parallelepiped gmesh, you can see the build meshes.sh that I can run. Now it's running, and doing this will create all the meshes in cylinders. You see there's a geofile and the associated mesh file, and the same is for the structured bifurcation. But in our case we did not need to do that, since we're creating the meshes directly from MATLAB with the function generate rect mesh. So let's run this file, the main file. So we set up everything, and then of course I have an error, which is here. We had a dimension mismatch because I did not clear the previous snapshots. So let's run again. Because this line clears all the snapshots from the reference solution, and if you use differing training dimension, you might have some dimension problems. So now I'm doing the vpod, the pod decomposition. I have everything. I'm running parallelepiped iteration number 2. Now the right part, the left part iteration number 3, the right part iteration number 3. And we have the error computed with respect to MATLAB. So here, our pod, we are not interested in this. So we have the relative error with respect to the computed reference solution that we had here, which is a coarse mesh. But we also have the relative error with respect to the fine mesh that we computed previously with FreeFrame. I hope that this tutorial helped you a little bit, and see you soon.